2.2 is a monster. It's a very large section. So I thought we would get going on this section today and tomorrow, and I'll begin introducing the concept to you via video, and then we will work on it next class as well. So we'll be kind of in a holding pattern with 2.2 for maybe 1.5 lessons. And 2.2 is about friction. So just in case, for those of you taking notes, hopefully some of you are, this is 2.2 from your textbook. And I'm going to address it in kind of a reverse order. I should start talking about normal force first and then the friction coefficient. Some might think I would, but I have a deliberate reason for this. And friction, to find friction, so the notation for it is F sub F is equal to F sub n times mu, which mu is the 12th letter in the Greek alphabet. I guess I ran out of letters to use in the Latin, the English or Latin alphabet, but so they went to mu, and it's this symbol here, this Greek symbol. I'm pointing at something, but you can't see me right now, so let me highlight it. Okay, try again. Okay, so this is mu. Anyway, we're going to, and I'm going to go ahead and speak about normal force a little bit now. So Fn is equal to the normal force. I can write quickly this way. Quicker. Okay, so that's a normal force. And I will cover that in a few moments, because you're probably thinking, what is normal force? You never even talked about it, but I'm going to mention it. Mu is a friction coefficient. So what do you think has more friction if you slide an object across it horizontally? Ice or a big piece of sandpaper? Well, obviously the sandpaper is going to have a higher friction coefficient than ice. Okay, so sandpaper is higher than ice because it's going to be more difficult. It's going to require more force to slide it in a horizontal direction because the friction is higher, right? So we're going to now look at Newton's second law, and that is that F is equal to ma. And I have to mention this as well. So Newton's, we're switching to Newton's because if F is equal to ma, then the mass is in kilograms. And the acceleration is in meters per second squared. So it's just easier, instead of writing all this, just call it Newton's. And that, anyway, anytime you're dealing with force, you're always going to use Newton's. All right, so this is mass. This will help you remember it. This is acceleration. Actually, I'll make it orange, a different color so you know. That's acceleration, and those are equal to Newton. So if you think, oh, I remember from that video, he showed us kilograms times meters per second squared. Kilograms mass, meters per second squared, acceleration, F is equal to ma, Newton's second law, and then go right there if they're talking about force. Just start out writing it down at the top of your test paper or whatever it is that, whether it's homework or whatever it might be. Okay, so F sub F, that's friction, that's the notation that's used, is equal to the normal force times mu. All right, that's the friction coefficient times the normal force. And here we go to, so force, as I mentioned, is always in newtons. And then, so we have newtons is equal to, and what I'm doing is I'm just putting the units for these two notations below, and obviously they're going to cancel out. So we're just left with mu, and there are no more units left. So mu has no units. So if the answer is 0.81 or something like that, you just write that. You don't have to worry about units when you're dealing with it. I encourage you, whenever you encounter a problem that's a little bit complicated, always draw this. It's called a free body diagram. So when we talk about inclined planes and declining planes, draw this. It helps you visualize it. It's very difficult to picture some of these scenarios in your mind. So this definitely helps. And then you have all the information there. I promised you I would talk about normal force, so let's talk about it. So first, let me start with the force downward, which is, we've already talked about, I think we discussed it briefly. It's the force due to gravity. So I'm just going to call it F sub G is equal to mg. Okay? So we have 20 times 9.81 for the force that's pulling you down. But you don't fall through the floor. You don't get pulled through the floor. So we have a force pulling us up. And that is called the normal force. So this isn't always the case, but in this section, this is the case. Wait, F sub n. In that the force pulling you down is going to be equal to the normal force, the force pulling you up. Otherwise, you would sink into the floor of the school or wherever you might be. All right? So for these problems, you can set them equal to each other. And let me show you, I try to break it down in a logical... Oh, darn it. Okay, let me try this. There we go. All right. And also, if there's a constant acceleration, if there's no acceleration and a constant velocity, the frictional force is equal to the force that's pulling the object in a horizontal direction. All right? And remember, the frictional force is equal to the normal force it's here equal to the normal force, which is equal to that, times the frictional coefficient, and which is the same as force. Here, let me color code this better here. That. So the frictional force is equal to this, the yellows, and now I'll do the blues is equal to this. And sometimes you don't even need the MA. Sometimes they just give you the force and they'll say it's 25 newtons or whatever. And I broke this component down a little further, that if you're dealing with normal force, F of n, right here, that's the same as mg. Okay, so it's going to be equal if you're not sinking, basically. And if you are sinking, then it'll say as such. But you're just going to assume that everything's stable, that this movement, okay, that movement is the same as that movement. All right, so please pause the video right now and read this question and try to answer the questions. And if you can't, it's no problem. We're just starting this. This is new to us, so new to you, I should say. So please read this and answer these 3 sub-questions, I guess you would call them, but the conditions are already written in this top part. Okay, for letter A, we know that the the force due to gravity is the same as the normal force, because this box isn't going anywhere. It's not rising, it's not sinking, so it's equal. So all you have to do to find the normal force is figure out mg and multiply the mass times gravity, and you're going to find the solution, which is equal to... sorry, I didn't write it down. But the mass is 15, and multiply that times 9.8, and you get 147 newtons in part A. Part B, for the frictional force, we want to find out the normal force times mu. And we have the normal force already, it's 147. And they give us the frictional force, which is 0.4. And the final answer, I wrote it down this time, it's 58.9 newtons. 58.9 newtons. And letter C is a little trickier, but it's still nothing we can't handle. If you apply a horizontal force to 60 newtons, will the box move? Well, obviously 60 newtons is greater than 58.9. Therefore, yes, if you're pulling the box this way, it's going to move because this is going to overcome the amount of force you're putting on it is going to overcome the 58.9, the amount of friction that's preventing it from moving. So the force that you're pulling beats the friction. It's higher, and I think it's pretty clear from there.